Ladder programming. Ladder logic programming is a graphical programming language, used in industrial automation primarily for programming programmable logic, controllers, PLCs. It visually represents the control logic of a system using a ladder diagram, which resembles a ladder with vertical rungs and horizontal rails. In ladder logic programming, the control logic is based on the concept of relays and relay contacts. Each rung of the ladder diagram represents a specific control function or operation. The contacts in the diagram correspond to the input signals and the coils represent the output signals. These contacts and coils can be either normally open, no, or normally closed, NC, depending on their behavior. The ladder logic diagram is read from left to right and the control logic is executed sequentially. The logic flow is typically determined by the state of the contacts, and the resulting actions taken by the coils based on the state of the contacts. Ladder logic programming is widely used in industrial automation, because of its simplicity and ease of understanding. It allows programmers to easily visualize and implement complex control systems using a combination of basic logic functions such as and, or, and not, as well as timers, counters, and other specialized functions. Overall, ladder logic programming provides a practical and efficient method for designing and implementing control systems in various industrial applications. Ladder logic programming rules. Every PLC manufacturer has slightly different ladder logic programming rules when it comes to building the logical expressions contained within a rung. Even a manufacturer with multiple PLC models can have varying rules depending on processing power of each PLC model. But there are 7 basic rules that all PLC manufacturers use for ladder logic programming. 1. A PLC scans each rung in the ladder diagram from the left-hand side to the right-hand side and from the top to the bottom. 2. The PLC scan runs in a repeated cyclic manner where the inputs are monitored, the rung logic evaluated, and then the state of the outputs are executed. The scan time is expressed in milliseconds, ms. 3. The logic state of the outputs is evaluated as the program scans through the rungs. But they are only updated at the very end of each PLC scan, simultaneously. 4. There must be at least one input or logic expression at the start of each rung. 5. There must be at least one output at the end of each rung. 6. Each rung in the ladder diagram represents one logic operation in the overall control operation. 7. An input, output, or logic expression can be used more than once in the ladder diagram. The same tag name and address is used to label it if used more than once.